Good day. I am Chotelina 1 of Math 3A. I am going to investigate the squares in a chessboard as for my mathematical investigation. Learning objectives are create number patterns from practical context and describe the general term for a sequence in words. First, how many squares are there on a typical chessboard? The answer is not 64. Why and how? So, let's first answer the question, how many squares are there in a 3 by 3 square? The answer is not 9. Why? Because there are different kinds of squares in a 3 by 3 square. There is a 1 by 1, 2 by 2, and a 3 by 3 square. So, how many 1 by 1 squares are there in a 3 by 3 square? There are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 1 by 1 squares inside a 3 by 3 square. How about 2 by 2 squares? There are 4 2 by 2 squares inside a 3 by 3 square. And obviously, there is a 1 3 by 3 square in a 3 by 3 square. So the number of squares in a 3 by 3 square is not 9 but 9 plus 4 plus 1 is 15. There are 15 squares in a 3 by 3 square. What about in a 4 by 4 square? Are we just going to count the black and white squares we see in a figure? No. Let us first identify the different kinds of squares there are in a 4 by 4 square. There are different kinds of square. There is 1 by 1, 2 by 2, 3 by 3, and a 4 by 4 square. So, how many 1 by 1 squares are there in a 4 by 4 square? There are 16 1 by 1 squares. How about 2 by 2 squares? There are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 2 by 2 squares inside a 4 by 4 square. What about 3 by 3 squares? There are 1, 2, 3, and 4 3 by 3 square, and obviously 1 4 by 4 square. What about if we are asked how many squares are there in an 8 by 8 square? To solve that, and also to solve how many squares are there in an n by n square, we cannot count it na. So we're going to find a formula to answer the questions, how many squares are there in an 8 by 8 and in an n by n square. So we are going to find the formula that we can use to find the number of squares in an 8 by 8 chessboard and to find the squares in a size of n by n, to find the number of squares in an n by n to find the number of squares in the size of n by n square. If you determine the number of squares on a smaller board starting with 1 square, you will readily discover a pattern that leads to a simple formula for a board of any number of squares. A 1 square board obviously has only 1 square. A 2 by 2 square board has 5 squares, the 4 basic ones and the 1 large 2 by 2 one. A 3 by 3 square board has 14 squares because there are 9 smaller, yung 1 by 1 plus 4 na 2 by 2 plus 1 3 by 3. In a 4 by 4 square board naman, it has 30 squares because there are 16 1 by 1 squares plus 9 3 by 3s plus 4 2 by 2s and plus 1 4 by 4 square. So, are you beginning to see the pattern? What would your guess be for the number of squares on an 8 by 8 board? So, we already know that the sum of n integers is squared with 1 squared plus 2 squared plus 3 squared up to n squared is equal to n times n plus 1 times 2n plus 1 all over by 6. But how do we know that? I will represent each term in the series with the equivalent number of cubes. So for 1 squared is 1 cube. For 2 cubes, there are already a measurement of 2 of width and measurement of 2 in length, so there are already 4 cubes. For 3 squared, there are 9 cubes. Up to n squared. We can see that the length, width, and height of this shape is equal to n as the last term in the series. Let's make 2 more copies of the same shape. So there are already 3, 1 squared plus 2 squared plus 3 squared up to n squared, or the n integers squared. Let the length be equal to n with 5 units. As you can see, the width has already 6 units, so length plus 1 is n plus 1 for our width. So as you can see in the figure, may mga kulang na parts sa ibabaw, so we can fill it by getting half of the units. Now the measurement of the height is equal to n plus 1 half of the units, so n plus 1 half for our height. Therefore, the number of cubes is n times n plus 1 times n plus 1 half. We can equate this in the equation 3 times of n integers squared, so 3 times 1 squared plus 2 squared plus 3 squared up to n squared is equal to n times n plus 1 times n plus 1 half. Let us factor out 1 half on the right hand side. So the formula to find the numbers or the sum of integers squared is equal to n times n plus 1 times 2n plus 1 all over by 6. So now we're going to prove the formula using the mathematical induction. But first, what is mathematical induction? Mathematical induction is a mathematical method which is used in proving a statement, a formula, or a theorem that is true for every natural number. The technique involves 2 steps to prove a statement, as stated. Step 1 is the basis step. It proves that a statement is true for the initial value. Step 2 is the inductive step. It proves that if the statement is true for the nth iteration or number n, then it is also true for n plus 1 iteration or number n plus 1. How to do it? Step 1 is consider an initial value for which the statement is true. It is to be shown that the statement is true for n is equal to initial value. Step 2, assume that the statement is true for any value of n is equal to k. Then prove the statement is true for n is equal to k plus 1. We actually break n is equal to k plus 1 into 2 parts. One part is n is equal to k, which is already proved, and try to prove the other part. So our induction hypothesis, replace every n in p sub k with k. So n is equal to k. So isa-substitute lang natin yung k dun sa n. So yung n multiply to n plus 1 multiply to 2n plus 1 over 6 is magiging k multiply to k plus 1 multiply to 2k plus 1 is equal to 6 is equal to k squared plus k minus 1 squared up to k minus 1 squared. Assume that it is true. So for the second one is n is equal to k plus 1. Induction hypothesis, k plus 1 is multiplied to k plus 1 plus 1 multiplied to 2 multiply k plus 1 all over by 6 is equal to k plus 1 squared plus k minus 1 squared up to k minus k times plus 1 squared. So, yan yung kanina. The next step is to expand. So, copy lang natin. And, imumultiply pala yung 2k plus k plus 1. So, next step is to expand. So, k plus 1 times k plus 2 times 2k plus 3 all over 6 is equal to k plus 1 squared plus k times k plus 1 times 2k plus 1 all over by 6. So, last step is to combine like terms. So, for 2k plus 3 plus 9k squared plus 13k plus 6 all over by 6 is equal to 2k cubed plus 9k squared plus 13k plus 6 is all over by 6. So, proves that the formula is correct. Now, let us answer the questions. First, how many white diamonds of all sizes like 2x2, 3x3, and etc. are in a chessboard? Number 2, how many black diamonds of all sizes are in a chessboard? Number 3, are there more black diamonds than white or vice versa? By what magnitude? Number 4, what is the total area of black diamonds, of white diamonds? Which color has greater area? By how much? And we're also going to compute the area of the diamonds, of the white and black diamonds. Now, we're going to answer how many white diamonds of all sizes with 2x2, 3x3. Ala, wait lang, wag kayo maingay. Now, let us answer the questions. How many white diamonds of all sizes of 2x2, 3x3, and etc. are in a chessboard? For white diamonds, there are 1, 9 plus 9. So, pinaghiwalay lang para hindi nag-overlap. So, merong 18 diamonds for 2x2 size. While for 3x3 naman, we have separate lang din yung tig-apat para hindi nag-overlap sa figure. So, merong 4 plus 4, we have 8 diamonds na ma-occupy sa 3x3 size. While on 4x4 naman, there are only 2 diamonds. So, to compute the area of the diamonds, we're going to multiply the size into the number of diamonds. So, for 2x2, there are 18 diamonds. 4 times 18 is 72. So, the area for 2x2, area of the diamonds, area of white diamonds for 2x2 is 72. 3x3 multiplied to 8, 9 times 8 is 72 also. While for 4x4 naman, there are only 2 diamonds, so 16 times 2, the area is 32. And now for black diamonds, for 2x2 size, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are also 18 diamonds for 2x2 in black diamonds. While for 3x3 size, there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 diamonds. For 3x3, for 4x4, there are also 2. So, to compute the area, size multiplied to number of dias. For 2x2, there are 18. So, 4 times 18 is 72. The area for 2x2 in black diamonds is 72. While for 3x3, multiplied to 8 is 9 times 8, also 72. The area for 3x3 size for black diamonds is 72. While for 4x4, There are 2 diamonds. 16 times 2 is 32. Are there more black diamonds than white or vice versa? By what magnitude? The answer: there are equal amount of black diamonds and white diamonds. What is the total area of black diamonds, of white diamonds? Which color has greater area, by how much? So we already computed the area of the black diamonds and white diamonds a while ago. So we're just going to sum up. The total area for white diamonds is 72 plus 72 plus 32 is equal to 176. And the total area for black diamonds is also 72 plus 72 plus 32 is also 176. Because the black and white diamonds have the same amount of area. That is all for my mathematical investigation. Thank you for listening.